Are we alone in the universe? This age-old question has captivated humanity for centuries. Now, thanks to groundbreaking technology, we are closer than ever to find the answer. Join us on a journey through space and time as we explore the incredible world of exoplanets and discover how the latest scientific breakthroughs are helping us detect these distant worlds. From the comfort of your own home, buckle up and get ready to embark on an unforgettable adventure. What is a transit? Most known exoplanets have been discovered using the transit method. A transit occurs when a planet passes between a star and its observer. Transits within our solar system can be observed from Earth when Venus or Mercury travel between us and the Sun. Transits reveal an exoplanet not because we directly see it from many light years away, but because the planet passing in front of its star ever so slightly dims its light. This dimming can be seen in light curves, graphs showing light received over a period of time. When the exoplanet passes in front of the star, the light curve will show a dip in brightness. Why are transits important? This data is part of why transits are so useful. Transits can help determine a variety of different exoplanet characteristics. The size of the exoplanet's orbit can be calculated from how long it takes to orbit once, the period. And the size of the planet itself can be calculated based on how much the star's brightness lowered. We can also learn about an exoplanet's atmosphere during transit. As it transits, some light will go through its atmosphere, and that light can be analyzed to determine what different atmospheric elements influenced its particular dispersion. Atmospheric composition is important in determining habitability. Habitability can be further shown through orbital size and star temperature. This help determines the temperature of the planet itself, thus telling us whether its surface is a comfortable temperature or unsuitable for life. Why is transit method good? The dimming of a star during transit directly reflects the size ratio between the star and the planet. A small planet transiting a large star will create only a slight dimming, while a large planet transiting a small star will have a more noticeable effect. The size of the host star can be known with considerable accuracy from its spectrum, and photometry, therefore, gives astronomers a good estimate of the orbiting planet's size, but not its mass. This makes photometry an excellent complement to the RV method, which provides an estimate of a planet's mass, but not its size. Using both methods, combining mass and size, scientists can calculate the planet's density, an important step towards assessing its composition. How do we detect exoplanets by the transit method? NASA has found thousands of exoplanets by observing planetary transits. The Kepler mission was designed to explore the diversity and structure of exoplanetary systems. Its 9-year mission resulted in thousands of confirmed exoplanets, and due to how much data was produced, thousands more in the process of confirmation. TESS, Kepler's successor, is currently in space on a 2-year mission to discover potentially 10,000 more transiting exoplanets in orbit around bright host stars in our solar neighborhood. During Kepler's primary mission, it fixed its telescope on only one section of the sky. TESS covers an area 400 times larger, searching almost the entire sky. For centuries, astronomers have speculated about the existence of planets beyond our solar system. After all, with between 100 and 400 billion stars in the Milky Way galaxy alone, it seemed unlikely that ours was the only one to have a system of planets. But it has only been within the past few decades that astronomers have confirmed the existence of extrasolar planets, aka exoplanets. Astronomers use various methods to confirm the existence of exoplanets, most of which are indirect. Of these, the most widely used and effective to date has been transit photometry, a method that measures the light curve of distant stars for periodic dips in brightness. These are the result of exoplanets passing in front of the star, by transiting, relative to the observer. These changes in brightness are characterized by very small dips and for fixed periods, usually in the vicinity of 1/10,000th of the star's overall brightness, and only for a matter of hours. These changes are also periodic, causing the same dips in brightness each time, and for the same amount of time. Based on the extent to which stars dim, astronomers are also able to obtain vital information about exoplanets. Exoplanet transit. When exoplanets pass in front of their host star, as seen from Earth, a portion of the start light is blocked out and a decrease in the photon flux is measured. Measuring the change in flux over time allows for the creation of a light curve. Fitting models to the light curve, various characteristics such as orbital motions and atmospheric composition can be extracted. Both the size of the host star and the planet will determine the decrease in flux during the transit. The orbital distance between the exoplanet and its host star does not affect the transit depth due to the enormous distance from Earth. The transit method is particularly useful for calculating the radius of an exoplanet. For example, a smaller planet will block a small amount of light, while a bigger one will block a lot of light and create a bigger transit light curve. So, by examining the light curve, we can find the size of the exoplanet. Moreover, if the transit happens for a long duration, it means that it is taking a long time for a planet to orbit its host star, which means the planet is at a longer distance from the star. The transit method is a very useful tool in not just finding exoplanets, but also helps in studying different properties of that planet. When the planet blocks the light from the star, some of its light also passes through the atmosphere of the exoplanet. By studying that light, astronomers can tell the atmospheric composition of the planet. If it hosts any form of life, we will know. Moreover, we can also figure out the temperature of the planet through this method. This method has been very successful in finding other worlds. NASA's Kepler Space Telescope used this method to find thousands of planets from 2009 to 2013. As we reach the end of this incredible journey, we are left in awe of the vast expanse of the universe and the groundbreaking technologies that allow us to explore it. The discoveries made through the detection of exoplanets not only deepen our understanding of the cosmos, but also give us hope that there may be life beyond our planet. The possibilities are endless, and the future of space exploration is looking brighter than ever before. So let's continue to push the boundaries of what we know and strive to unlock the secrets of the universe. Thank you for joining us on this unforgettable adventure, and we look forward to sharing more groundbreaking discoveries with you in the future. Be sure to subscribe to our channel, or you will